Hello everyone. It's another stream just to let you guys know what's going to happen pretty much tomorrow morning during the test. So let's go ahead and get onto it, alright? So I'm just gonna get this done right here real quick. I'm gonna increase this real quick. There we go. So we get this ones first, alright? First of all, we need to get ourselves a we need something for this type of robot chill hub. Taking too much time on this one. There we go. Okay, guys. So technically, we're going to be assessing tomorrow morning. Everything is about convection, conduction, and radiation. It's been explained. It has been explained during class, during labs. Pretty much, you are fully aware of what's going on when we're talking about conduction, convection, and radiation. So just to make sure that you guys get the idea, we're going to go through several different examples, exercises, and the definitions. And later on, we're gonna go really fast through flashcards on Quizlets, and that's pretty much everything's going to be explained today. So we're gonna go and start with conduction. Conduction is the transfer of the thermal energy through contact. You need to be in a direct contact with the object that's your heat source, or anything that has pretty much more thermal energy than your other subject. So thermal energy is transferred from hotter places to the colder places. So let's say you have a heat source like a hot plate or the stove, and you place your hand over that. The thermal energy will be transferred to your hand, obviously getting yourself injured and burned. But my point is, all the thermal energy will be transferred, or it's going to be transmitted in a way to your hand, making you feel pain, yes, but the idea behind it is just the transfer of the thermal energy. So let's just take this for example. That might be not a good example. You don't do that at home, right? Please don't do that. Now, let's take for example the sample 2. Okay, you're in this little B graphic on our focus folder. Let's take sample 2 for example with 38 Celsius degrees. Okay, we do have a sample 1 with 30, and we do have a sample 3 with 28. But which one is hotter? This one right here. So in reality, okay, what's going to happen if they ask you something about what's the thermal energy transfer? What's the thermal energy transfer from sample 2 and sample 3? Well, it's easy. You just need to go for the hotter source, or the heat source, which is going to be your sample 2, and it's going to be transferring all that thermal energy to the sample 3. So how it's going to be transferred? By conduction. Okay, they're touching each other, they're close to each other, they're touching each other, and sample 2 will be transferring that thermal energy until they balance out. Once they're balanced out, once they do have the same temperature, the transfer stops completely and the whole system is balanced. That's pretty much all there is to it when we're talking about conduction. Conduction is simply transferring all the thermal energy from one point, which is hotter, to the other one, which is colder. In this case, sample 2 to sample 3, and also, if they happen to ask you, sample 2 to sample 1 as well. Because as you can see, both sample 1 and sample 3 are colder than the sample 2. Therefore, thermal energy will be transferred from sample 2 to both sides, to your left and to your right. Conduction is just, again, transfer or thermal energy from the hotter part to the colder part. Let's say you have a plate of soup. Okay, soup is extremely hot, and you put a metal spoon in it. There will be a time when you hold on the spoon and it will increasingly starting to, like, you're probably not going to feel the burn, but you will definitely feel that hotter and hotter as it goes. The reason is because in that, let me just make sure that you understand this part. Let's say these hot soup plate right here, we have it, and what's going on is that everything that's inside of it has way greater thermal energy than whatever you're putting in, right? So the heat source will be the soup. And if you're placing a metal spoon, that conductor material will conduct by, again, being in direct contact with it, all the thermal energy to the tip of it, which is a colder area of the metal spoon. So by the time you hold on to it, all right, you will have more thermal energy on the tip of that spoon that you put inside of a plate than when you previously put it, like at the beginning of whatever your meal or whatever it was. So again, just to make things easier, transferring the thermal energy from one point to the other, the hotter to the colder. Now let's go to convection. Convection happens only with gases and liquids. And it is a little bit easier to explain when you see a graphic. But let's go take a look at this one, because I know I had a really good explanation of this one right here. So what we do have, convection, is just the, let me just take this one in here real quick. The heat source will be the bottom of your pan, your pot. All the water that we have in here will rise due to the temperature that is rising. Just gases and liquids, they just rise, okay? And then what we do have in here is that as they reach the surface of the water right here, the room temperature will cool it down, not cool it down to a point that you can just stick your finger in it and it won't hurt. It's just to a point that it's way colder than the one at the bottom. That will make that water sink and reheat again. So technically what happened is it heats up, goes up, cools down, goes back down, heats up again, goes up again, cools down again, goes back down, and it keeps on repeating. It's a perpetual thermal energy cycle. It doesn't stop. That's what makes our air currents on planet Earth happen. That's what makes our ocean currents happening on planet Earth as well. So this is a perpetual motion of thermal energy in our planet, and that's how it works, by convection. Convection is just cycling all that thermal energy. Heat goes up, cools down, it brings it back down, it heats up again, heats up again, goes back up, cools down again, goes back down, it keeps on repeating the cycle forever. This might be the best explanation out of it. Whenever you see like gases or liquids, most likely if you see like arrows cycling, most likely we're going to be talking about convection. Just have that in mind. Radiation is another example that we are going to be talking right now. And the best example for me is kind of like having a Wi-Fi connection. The closer you are to the source or router, then the signal or the energy transfer. The thermal energy will be transmitted to you the closer you are to the source. Let's say, for example, when the planet Earth gets closer to the sun, or the location of you on planet Earth gets closer to the sun, Then you get summer season. As you move farther and farther away from the sun, again, your location, not the planet Earth itself, um, your location on planet Earth gets farther away from the sun, we get the fall and winter. So that's radiation for you. It's just the energy, or the thermal energy traveling in waves, reaching you, and that's it. That's pretty much all there is to it. It's just like wirelessly sending all you that information or that energy. The closer you get from the source, the warmer you get. But it's just no contact, no nothing. It has no medium. They're on their own medium, just like light. It travels through space, just like radiation also. It travels in waves and also goes pretty much everywhere. In this case, in every direction, possible direction that it's pointing this out. Now, as you can see, this one right here in this example, they're holding a metal spoon. If you could just like try to comprehend what's going on, as this heats up by radiation, the conductor material will take, by conduction, because they're touching, all these molecules of this metal are touching each other, they will conduct all that thermal energy all the way to the hand of this dude, which is about to get burned. Again, conduction, touching, radiation, they're not touching at all whatsoever. They're just having that energy transmitted from one point to the other. And guess what? It's always going to be from the hotter area to the colder area. Again, just the example that we did with the ice. An ice cube placed on your hand will be like your body temperature has, it's way more, your body temperature has way more thermal energy than the ice that you will place in your hand, making your hand, and in all that thermal energy to the ice, making it melt. That's pretty much why the ice melts faster in your hand than placed in a cup of, or in a cooler, or something that keeps them cool. Other than that explanation, I don't think I can just help you out with anything else without actually telling you the actual answers. There will be two questions, if I'm not mistaken, about density, calculate density, and how to use your density formula. And the rest of 11 or 12 questions will be multiple choices on radiation, convection, and conduction. If this is not easy enough for you to understand, then we'll have our little picture right here, having this fireplace or fire pit, having convection as the air is rising, as it heats up in this place, rises, and you get to feel it in your hands. As you get closer and closer and closer, but not immediately above it, you get radiation. It spreads pretty much everywhere, surrounded the heat source. Radiation travels in waves again, and it warms up your palms of your hands by just being close to the source. And as you can see, this tip part of this metal bar, this metal rod is heating up by convection and radiation, but this person right here holding it will feel it through conduction. That's pretty much all there is to it, guys. Let me just go to the flashcard real quick so we can just end up this stream real fast. Remember, this will be in YouTube. You can just go and check it. Make sure that you I don't know, man. Just go watch it. Try to comment on those videos if you have any doubts or any questions. I'll just jump on it and try to answer as fast as possible. Now, I'm going to go and follow several flashcards that we do have in here real quick and really fast. And by the time we finish all these 17 flashcards, we should be able to know pretty much every single concept about radiation, conduction, and convection. So the direct transfer of heat between an objects that touch, again, if they're touching, we know that thing is conduction. So conduction. This one, again, cycling. Warm air rises, cool air goes back down to rise up again as it heats up and keeps on in perpetual motion. The transfer of heat as a result of the rise of warm gas or liquid, we call that convection. Okay? Sun, the transfer of heat through a space by wave. The sun, if you had anything talking about the sun and earth, we get it by radiation. Sun emits and transmit all that thermal energy to planet earth, and we receive it on a daily basis pretty much. And as I said, as we go closer to the heat source, we will receive more thermal energy, or we get more thermal energy from the sun. As we move farther away from it, we get winter season, which is pretty much colder that we can get on planet Earth. Next one. Oh, this one we already made sure that during our presentation we watch pretty much everything that we had in here. Heat moving from a warmer object to a cooler object. Warmer to cooler. Okay? It's heat transfer. That's what we call heat transfer. We're taking this heat source and we're sending them in pretty much every different method possible. When a light bulb emits light is an example of radiation. It emits light, but also it's emitting some thermal energy, especially if those are the regular light bulbs. If it's LED lights, you will get some type of radiation, like thermal energy being radiated by the actual LED light, but it's not going to be as much as your regular light bulb. Next
Radiation.
one. That was my mistake. I clicked when...
Campfire emits light and heat is an example of.
Campfire emits light and heat. And this is an example of what? Radiation. When you see some radiant object, just like the sun or like a fireplace, for example, and you get to feel the warmth of it, you're in the presence of thermal energy being transmitted to you by radiation. Next one will be a microwave. We did this today on the Popcorn Lab. A microwave oven is an example of radiation as well. They're not touching anything. They're just sending all those microwave through the food, and they're making all those molecules inside of the microwave to vibrate. And remember, the more motion the molecules has, the more thermal energy they have. That's the reason why when you're freezing and you're frozen, you don't move. Like things that are freeze, pretty much frozen, they just stopped. Next one, a metal spoon. We already did this one. It's your matty chan soup, and the metal spoon will heats up after it sits in a hot soup. That's an example of conduction. Remember that if you are having your heat source right here, it will be transferred through conduction. Remember that all those molecules are touching in the metal spoon. All these molecules are touching each other. And then it will be transferred through conduction to the tip of the metal spoon. Whenever you grab it or you get a hold on it, you will feel it. Next one, a hot or pan heats up on a hot stove. It's an example of conduction. These ones are directly touching each other. Okay? These are directly touching each other. What happens inside of it will be known as convection. Boiling water. Again, what's happening inside of a pot or the pan will be an example of convection. The water at the bottom of it, let me just use this real quick so we can explain it. The water at the bottom of it will rise and will cool down at the surface because they're being exposed to room temperature. As it cools down, it goes back down to only to be heated up again, rising up, and then being cooling down again by the room temperature that's on the surface of the water. And then we get again a perpetual cycle of thermal energy. Hot air balloons. Again, air heating up, rising to be cooled down again up there in the atmosphere and then being brought back again to Earth. So heats up, cools down, heats up, cools down. Again, convection. Number 12, total measure of energy within a system. The faster the particle move, the warmer it is. We are pretty sure we know this. This is known as thermal energy. Thermal energy is the definition of how much the molecules within a body are moving. A cycle of motion of fluid, gas and liquids again, gases and liquids only, that is due to the fact that warmer objects are less dense and cooler objects than the others. This is an example of convection. Remember, every single time you see arrows spinning or cycling, and the thermal energy, it's pretty much, let's just go and say recycling. It's not recycling because there's some lost energy right there. We're in the presence of convection. Average measure of energy of all the particles in the material measured with a thermometer. That's just temperature. Okay? And particles that get hot move more, move apart, become less dense, and expand. We're not going to go into this, but this is thermal expansion. It's pretty much whenever or dilatation. Whenever a body heats up, it pretty much expands, and that's the reason why your tires, whoever gets a car at home, gets all the pressure in the tires gets way higher when it's heat up than in colder days. A material that allows heat and electricity to pass through it is a conductor material, and mostly metals are the ones that we're gonna be using to portray these type of examples. And lastly, but not least, a material that does not allow heat or electrons to move through it easily, we call that insulators. Insulators just pretty much stop the motion of those electrons and the thermal energy, and avoids the pass of it like as easy as a conductor would do. So guys, that's pretty much all there is to it. Really wish you get to see the whole thing, and hopefully that will be an asset for you tomorrow. So make sure you watch it, you understand it. If you don't, just toss a message over there, toss a comment on the comments below, and just make sure that you get your questions put out so we can just answer it really quick. That will be it for now. And make sure you get some rest. Go to sleep at 10 probably. And have a good night. Good luck tomorrow, guys. See you tomorrow. Bye-bye.